Hello electrical engineers, this is Mo, your instructor. In this lecture, I'll teach you how to achieve effective discrimination with graded protection. In electrical power systems, discrimination refers to the selectivity of protection devices. In electrical system, there are protective devices such as circuit breakers and fuses that are designed to respond to faults, abnormal conditions such as a short circuit or overload in the system. These devices need to be coordinated to ensure that the one closest to the fault responds first. When a fault occurs at a specific point in a network, it needs to be cleared or isolated to prevent further damage to the system. Clearing a fault involves interrupting the flow of electrical current to the affected area. The sequence of operation. The outgoing protection devices installed in a distribution board must trip faster than the incoming protection devices. The outgoing refers to the branch circuit breaker and the incoming refers to the main circuit breaker. Or in other words, upstream and downstream. Upstream circuit breaker is the one close to the supply, and downstream circuit breaker is the one close to the load. Discrimination ensures that only the protection device closest to the fault operates to clear the fault. Other protection devices further upstream remain unaffected, allowing the rest of the system to continue functioning. Total discrimination refers to a specific condition related to the coordination of circuit breakers in response to different fault currents. In electrical system, faults can occur due to abnormal conditions such as short circuits or overloads. Fault currents are the currents that flow during these faults. In this panel, we have two circuit breakers called D1 and D2. These are protective devices installed in the electrical network. Each circuit breaker is responsible for interrupting the current flow under certain conditions, particularly during faults. These breakers have two states, open and closed states. When a fault occurs, the protective devices need to respond appropriately. Opening a circuit breaker means interrupting the flow of current, while closing it means allowing the current to pass. In the case of total discrimination for all fault current values ranging from overloads, excessive current within the normal operating range, to the non-resistive short circuit current, maximum current during a short circuit, circuit breaker D2 opens and circuit breaker D1 remains closed. In simpler terms, regardless of the magnitude or type of fault current, circuit breaker D2 is designed to respond by opening to isolate the faulted section of the system. At the same time, circuit breaker D1 remains closed, indicating that it does not trip or open during these fault conditions. This selective operation ensures that the fault is cleared efficiently and only the necessary portion of the system is isolated while the rest continues to operate. This coordination helps in maintaining the reliability and stability of the electrical network. Effective discrimination in electrical protection can be achieved through the use of graded protection, particularly by employing protective devices with different ratings. Discrimination refers to the ability to selectively isolate a fault in the electrical system, ensuring that only the minimum necessary portion is disconnected while leaving the rest of the system operational. Graded protection involves using protective devices with different ratings in a coordinated manner. The key idea is that the speed of operation of a protective device increases as its rating decreases. For example, using circuit breakers of different ratings 15 ampere, 30 ampere, and 60 ampere, the speed of operation or the time it takes for the protective device to respond to a fault decreases as the rating decreases. For instance, a fault current of 200 ampere will cause a 15 ampere circuit breaker to operate in about 0.1 seconds, and 30 ampere circuit breaker operates in about 0.4 seconds, and the 60 ampere circuit breaker operates in about 5 seconds. So the 15 ampere circuit breaker responds faster than the 30 ampere circuit breaker, faster than the 60 ampere circuit breaker. So in a circuit with these graded protection devices, effective discrimination can be achieved during a fault. The 15 ampere circuit breaker will operate more quickly than the other protective devices, ensuring that it responds first to isolate the fault. This selective operation prevents unnecessary disconnection of the entire circuit. In this way, we ensure security of supply. Security of supply ensuring a reliable and uninterrupted power flow to the non-faulted parts of the system, which is a crucial consideration for electrical designer. Effective discrimination is essential to maintaining the security of supply.